Welcome and hello. This is a video lesson in WRIMS, and in this lesson, I'm going to be talking about decision variables. In the user's manual there for Russell Plus language reference right here on starting on page 13 and page 14, there are 4 different decision variables used in the Russell Plus language. We're going to talk about those and also create an example and show some results and how they work in the WRIMS application. All right, so to get things started, I'm going to bring up a very simple model schematic and talk about it just in general terms before we actually look at any code and run any programs. So take, for instance, we have an inflow that enters node 1, and then we have 4 different channels that leave node 1. Each have their own different decision variable type. So we have continuous, bounded, binary, and integer. Okay, so let's just go through a quick problem example. I've grayed back the previous text, and now in black bold courier font, I've entered the decision variables names. So I'm going to use I_1 for the inflow, C_1_ cont for the continuous decision variable, bounded, integer, and binary. Next, what I'm going to do is add in blue text. These are going to be the coefficients to each decision variable value in the objective function. So we have 5, 6, 7, and 8. So the binary at 8 is the highest number. So the linear programming algorithm would want to route most of the water through that channel if possible. All right, in the next slide here, I've introduced the inflow. It's going to be 10. We'll just say 10 CFS. And if we were trying to solve this by hand, we would say we want to route as much of that 10 through the highest cost coefficient, the highest value here for which is C1 binary. But binary can only be 0 or 1, so we're going to be stuck with just 1. Okay, so in this bold purple, this is the flow rates, the actual resulting value for that decision variable. The next highest coefficient is 7. Now, what I'm going to do for 7 is I'm actually going to bind it to maximum of 5.4 and a minimum of negative 5.4. Also, for integer, I'm going to bind that between negative 3 and 3. So if there's a maximum of 5.4, and we're just going to that's going to be another active constraint. It's also going to be 5.4. So how much is left? 6.4, so 3.6. But the maximum through the integer is 3, which 6 is greater than 5. So we're looking at this decision variable over here. The value is going to be 3. And then the remainder is going to be 0.6, which is the flow through the continuous decision variable. All right. So let's go ahead and run WRIMS by setting up a program using these same variable names, decision variable types, the objective function coefficients, and then run the WRIMS and hopefully get these same values of 1, 5.4, 3, and 0.6. All right, so heading over to WRIMS, this file right here, args_channel.russell, this is going to define the 4 different decision variables. We start off with the word define. This is the first line here where we are defining the continuous decision variable. We have it labeled here, C_1_ and then open bracket std. That just basically means it's the standard type of decision variable, and it means it's non-negative, but there's no upper bound, and there's no other bound like it being binary or integer. After that, kind is a channel, and then the units are in CFS. So that's always going to be the same, kind, channel, and units CFS. For this particular problem, we're not interested in changing that. All right, so the next variable is our bounded decision variable. It's similar to continuous, except it does have a maximum and a minimum specified right here, negative 5.4 and 5.4. And then again, the units and the kind. And then the third variable is the integer type. So it also says integer right here, and then it has a lower and upper of negative 3 and 3 respectively. And then the last decision variable is our binary type. Now, the Russell Plus language reference does deviate from what I'm doing a little bit, just from trial and error. So for instance, binary, it talks about using this dvar keyword and then binary here and binary here. I wasn't having great luck with that. Maybe you will, but personally, I wasn't. However, in integer, decision variable, it mentions that the standard bounds for an integer variable are the same as binary, 0 or 1. So what I was able to do to create a binary decision variable is just to use the same style as integer and set the lower bound to 0 and the upper bound to 1. So that's what worked for me. All right, the next file over is the objectives. This is where we specify the individual decision variables and their weight. So for instance, binary had a weight of 8, bounded was 7, integer was 6, and continuous was 5. Okay. The next tab over just reads in that inflow. It's I_1. And then what I'm doing right here is I'm just referencing a file. It's my all data file. So I'm reading the inflow for all 12 months of a single water year from the all data table or all data file. It's covered in lesson 9, where I talk more about how to read inflows and demands from tables that are also saved locally. But anyway, I have an inflow and it's set to 10 CFS for the entire year. I also happen to have demand data saved in this table, but that's not used for this lesson. Okay. So also constraints, this is just mass balance. So the sum of the inflows equals the sum of the outflows, and there's no storage. So that's why the right-hand side there is 0. And then the main Russell file is right here, where we're just calling the inflows, the decision variables, the channels, the constraints, and then the objective function. All right, let's go ahead and see if that runs. I'm going to save all and then open up my RIMS. Right click. I'm going to just open up the run configuration first so you can get a quick glimpse of what I have saved here. All right, so I've got my DSS files ready to go. I don't have anything in the decision variable .dss file yet. See, no records. Okay, so that'll be populated when we run this. Single water year of 1922, and everything looks good. So we're ready to run. I'm going to go right click, run as, and then launch lesson 10 data. Okay, so it looks like that ran. Let's check out the results. I'm going to go to view, refresh catalog. Here are our 4 decision variables. Let's go ahead and click on this. So we have the same data as we expected to see from earlier. Let's see. So the integer is right here. This has the weight of 8, so that has a value of 1. It's going to be the same for all 12 months, so we can just look at the first row here. Our next highest decision variable coefficient was right here, the bounded decision variable, which had a max of 5.4, so that's maxed out at 5.4. And then the integer had a coefficient of 6, and its maximum value was 3 right there. And then the remaining through the continuous decision variable was 0.6, which is right here. All right. So let's go ahead and just modify the inputs a little bit, run the model, and see how the results change. I'm also going to just delete these values right here so I know for sure that what we're generating is new. All right, back to the PowerPoint. So this is our results from before. Say, for instance, I want to change this coefficient, the decision variable, the integer decision variable. Instead of 6, I'm going to change it to -6. So now what's going to happen is the first step and second step will be the same. We are going to definitely route water through C1 bin and C1 bound as much as we can, which is 1 and 5.4. However, through C1 int, if we route water in the positive direction, it's actually going to work against our objective function value. And remember, we want to maximize that value. So if the water is going the opposite direction, 2 negatives multiplied by each other will give us a positive value. The most negative value we can route through this channel here is -3. So if we're going to put a -3 right here. And then basically the difference is going to be routed out of this C1 continuous channel, C1 cont, which is going to be 13, 5.4, 6.4, so 6.6. All right, so let's go ahead and make that change. To do so, we'll go back into our files right here. We want to open up objectives.wresl. I'm just going to put a negative right there and then click on the save all. Let's go back to RIMS and then right click, run as, launch, and then to DSS view to look at the results, view, refresh catalog. Okay, we have results. Let's look at that table data. And as before, we have 1 through binary, 5.4 through bounded, -3 now through the integer, and 6.6 through the C1 continuous. All right, one more example, and then we'll call this good. So back to PowerPoint. Now what we're going to do is increase the upper limit on C1 bounded. Instead of 5.4, let's go ahead and make that 9.5. I'm just arbitrarily making up numbers here. So going through the process again, we're going to go 1 unit through binary because that still has the highest cost or the highest coefficient. And then after that, we're going to route 9.5 through the C1 bound, right? Even though we don't have 9.5 available yet, we will because we know this is going to be -3 again. So this is 9.5, this is -3, and then through the last C1 cont is going to be whatever's left, 2.5. Okay, so let's modify this upper bound to C1 bound coefficient and see what happens. I'm going to go to arcchannels.russell, and instead of 5.4, I said 9.5, and then save. Okay, I'm going to go back to DSS and clear this out. Okay, so that's clear. Let's go to WRIMS now, and then right click and run as and launch. Okay, so that's good. And view, refresh catalog, select all, and then here is our table data. 1 through binary, 9.5 through C1 bounded now. Again, -3 through integer, and then 2.5 through the C1 cont. All right, well, that's all I had prepared for this lesson. What we did in this lesson was talk about the different types of decision variables, continuous, bounded, integer, and binary. We modified some of the upper and lower bounds as well as the objective function coefficients, ran the model a few times, and then looked at the results.